Good morning to you. Okay, yeah, we're going to continue with this. Hope we had a night with a full of blessings, and as well as this morning, I will bless you with another revision question. Okay, so we'll go to question 2 today, which reads Figure 2 shows the process of fate of glucose produced during photosynthesis. The letters C to I represent their processes. Okay, so we have photosynthesis of glucose that is produced there in that big bar chart. Okay, now we have those letters I to C. Okay, so that means that this is how glucose, after being produced from photosynthesis, which we know very well, and that is how it is being used or by many processes. So there is energy at the end, so it means that the same glucose is able to be is being converted into energy. The same glucose, it is used in the making nucleic acid. The same glucose is used to make cellulose, and the same glucose, it is converted into starch, and the same glucose, it is converted into fats and oils, and the same glucose, it is converted into sucrose as well as into proteins by adding it to amino acids. Okay, so all those end product that we have mentioned here, by these processes, they are made by adding glucose. Okay, so now let us go to question 1. Let us go to question 1. So question 1. So this question is coming from is coming from it's coming from photosynthesis as well as metabolic reactions. Okay, as well as metabolism. Of course, it's much of metabolism questions here, because let us go through these questions. You understand what I'm saying. Question A, define the process of represented by the letter I. Okay, so these are just, there are a lot of chemical reaction that takes place to come up with this product. So metabolism is the sum total of chemical reaction that takes place within a living organism. So define the process represented by the letter I. So I, where glucose is converted into energy, and there is no other process other than respiration. So the answer there is respiration, which is the process by which glucose is broken down to release the energy. Okay. Then question B, identify a process in figure 2 which represents a catabolic process. Okay, catabolic process is a process by breaking down of larger molecules into smaller molecules. So any chemical reaction that leads to breakdown of small molecules into larger molecules into small molecules, that is catabolic process or reaction. Okay, so if you look at those above, which one leads to breaking down? I think there's no other than I, which is what? Respiration, because you break down glucose in order for you to have what? Energy. Then question B2, anabolic process. So anabolic process, we have a lot of processes. Actually, all the rest of the processes, they are anabolic process, because anabolic process is building up of small molecules to make one molecule. Okay, so for example, process C. Okay, process C, small amount of glucose is put together to amino acids so that you come up with what? Protein. So process C, it is also what? A type type of anabolic reaction or process, even F starch. Okay, so for you to have a starch, you need to come up with a small units of glucose. You put them together, and you come up with what? You come up with a starch. Okay, by what we call quantization process or reaction. So almost all these are done by quantization process. Okay, then we go to question C. If this fate of glucose was in human body, okay, 1. Identify two processes from figure 2 which would take place. Okay, two processes that would take place. Number 1 is process number I, which is respiration, because respiration is a characteristic of living organism. Even in human beings, takes place in plants and any other living organisms that you know. Then number 2, it is also C, which is the synthesis of proteins. It takes place in human beings as well. So process I and process C, they can still take place even in a human being. But also process E, fats and oils, it can take place. And starch, glucose, those two are in plants. Also H can take place also even in animals. Okay, then number 2, state the form in which the glucose could be stored. Okay, if it was in human beings, glucose could be stored in the form of glycogen. Okay, glycogen. Glycogen is Glycogen. Glycogen. In plants, it is stored in the form of starch there under process F. But in animals, which is a human being, it can be stored in form of glycogen. D. Name to industrial application of process I. Okay, respiration. So industrial application of process I, number 1 is baking. During baking, glucose react with yeast, and that forms what we call fermentation. Okay, now when glucose is fermented during the process of baking, it will release energy, and that is the heat energy that we express when you are baking. Okay, and also carbon dioxide will produce. You remember that the process of respiration, there is carbon dioxide which is produced. Okay, that is one of the products that will cause the dough to rise. Okay, yeah, when you are baking. So respiration is used in baking and also in brewing. Okay, in making alcohols. So brewing and also baking, those are the processes that can be those are the uses of what respiration in industry. Okay, there's brewing, baking, and yeah, maybe biofuel and so forth. So those are the processes those are the uses of process I, which is respiration in industrial. Okay, so now if you like it, follow me on my page, YouTube page, nephanis.rh, and the Instagram, and also you follow me on Facebook, nephanis.science. Okay, those are my pages. Please follow, comment, so that I know what you like and what don't like. Ask questions, and also please don't forget to share. Subscribe to my YouTube channel and share to others. Please give a like so that I continue doing what you want. I tell those that are in examination classes like grade 12 at the moment, please follow, and you can make it in science, physics, biology, and chemistry. And if you have anything to do with the principles of accounts and commerce, please notify me so that I know in the comment section. Thank you. Bye-bye. Good morning.